Hello class, this is a continuation of angles of elevation and depression. In these next few videos I'm going to be going through just, examples, plenty of examples just to get your thinking on the right path. Here we go. The angle of elevation of the top of a flagpole as observed from, remember I'm highlighting the word from, a point 15 meters from its base. Okay, this is a little bit confusing, but that's okay. So let's find a point from. So from a point. So here's any old point. Let's say this is the ground. Let's put this as P for point. So from a point 15 meters from its base. So let's draw a straight line from the base of something we don't quite know yet. Here's the base. Let's put B for the base. So let's read this again. The angle of elevation of the top of a flagpole as observed from a point 15 meters from its base. Okay, so we're talking about the base of a flagpole. Here is the flagpole. Let's just draw it as a straight line. There we go. Let's put this top bit as F for flagpole. Okay. And we have this angle here, 63 degrees. So we know from a point, the angle of elevation is 63 degrees of the top of the flagpole. So here's our horizontal line of sight. Someone's standing here, and they look upwards to the top of the flagpole, like so. And there we have a right angle triangle. What do you know? Now, in case you were a little bit confused, whenever we draw these scenarios, we always assume there to be a 90-degree angle with things like flagpoles or cliffs or mountains or even watchtowers or things like that. So 63 degrees belongs here because it's the angle of elevation looking straight ahead and then going upwards. And then the point is 15 meters from its base. So here we have 15 meters. Calculate the height of the flagpole. Well, if this is the top of the flagpole and this is the base of the flagpole, this here must be the height. Let's put that as H for the height. So let's use some trigonometry to calculate this missing value of H. So from this angle, our reference angle, we have, well, this is opposite from the angle, so let's put this as O for opposite. And this side here is very close to it, so that must mean that is an adjacent. So opposite and adjacent, that must use tan. So tan of 63 is equal to H over 15. As you've seen this before, we can multiply both sides by 15. We get 15 tan 63 is equal to H, and H is equal to, inputting it into our calculators, 15 tan 63 gives us 29.439, and let's round this off to 2 decimal places, 29.44 meters. It's a rather large flagpole. That is 2 decimal places. I'd like to invite you now to pause the video and give this second one a go. Okay, and I'm going to be answering it in 3, 2, 1. Here we go. So the angle of depression from the top of a cliff. So we can already draw this, the top of a cliff, from the top of a cliff. So let's just draw a hypothetical top of a cliff. Here's a point. And let's draw a line going straight down. And that there is our cliff. Yes, it's a straight cliff face. So let's put this as T for the top. Okay. The angle of depression from the top of a cliff, so 135 meters above sea level, to a boat is 37 degrees. In case the sentencing looks a bit weird, the comma, so from the top of a cliff, 135 meters above sea level, that must be referring to the cliff. So we know the height of the cliff is 135 meters. And we can reread this question again as, and once we have this information, we can ignore what we've already used. So the angle of depression from the top of a cliff to a boat is 37 degrees. So from the top of a cliff to a boat, he's looking downwards. So there's a boat here. Put B for boat, is 37 degrees. Now be careful at this point, because a lot of people are tempted to say, well, they draw a line like this, which is correct. A lot of people are tempted just to put, oh, this is 37 degrees. That is incorrect, because if we recall, the definition of the angle of depression is between the horizontal line of sight like this. There's the horizontal line of sight to the end point. So they're looking here, but they were looking here. So this here is 37 degrees. Now at this point, we want to calculate the distance of the boat from the base of the cliff. So that really what we want is this distance here. Let's draw another line. We know that this to be a 90-degree angle, and this is our distance, D for distance. Okay, so we can almost get a triangle here, but what we really need is the angle inside here. So if this is 90 degrees, this angle plus this angle must equal 90. So if we do 90, 90, take away 37, that gives us this angle in here to be 53 degrees. Now from here, we can use trigonometry to calculate the value of D. So 53, from this angle, it's inside the triangle now. From this angle, we have an opposite and an adjacent. So that must mean we are to use tan 53 is equal to D for distance over 135. Multiplying both sides equals D. D must equal, using our calculator, 135 tan 53 is equal to 179.151. Rounding it off to 2 decimal places, there we have it. Hope that gave you an insight into solving questions involving angles of elevation and depression. See you in the next video.